Okay. Now we are going to hear this talk by Ioannis Votsis.
So very glad to be here. I want to thank first of all Maria and Moises for organizing this conference. I'm not sure if anybody else was involved, but thanks for all the organizers. Thanks to UNAM, and I'm so glad to be in this beautiful country. It's been a long time coming. I used to live in California and I never made the trip down south. I feel so guilty about that. And now I managed to rectify that. Okay, so today I'm going to talk about concept defectiveness and amelioration. It's not really a topic that I've worked a lot on, so this is new work, but I'm hoping that it's going to turn into something relatively substantial. So let me give you a little bit about the scope exclusion of the talk, so what I'm not going to do in this talk, and then a little bit about what I am going to do in this talk. So the talk is not about the metaphysical, the metaphysical status of concepts. That's a huge debate concerning what concepts really are, whether they are abilities, Freudian senses, mental representations. I'm not going to touch on that, okay? There's also a debate over empiricism and nativism. Again, I'm not going to touch on that. So whether or not we have inborn, innate concepts or whether we acquire them through empirical means. There's also various debates, in fact. I say debate there, but the third one is actually various debates concerning the relationship between language and concepts. Things like whether there can be concepts without language. And I'm not going to really talk about any of these things. So what I'm going to talk about, though, is the pluralism versus monism debate over concepts. So I'll explain that in a second. The debate over the structure of concepts. So I'm sure most of you in here are familiar with the classical theory of concepts and the prototype theory. There are other competitors, but I just don't have enough time to talk about those. And finally, the more substantial part, I guess, and the less tentative part of the talk is going to be about defectiveness, and in particular, a specific kind of defectiveness, which I call extensional inadequacy, the extensional inadequacy of concepts. Okay? So here's the plan. In the first part, I'm going to give you I'm going to talk about this general debates over concepts. So that's divided into two parts itself. One is the pluralism-monism debate. The other is the classical versus prototype theory debate. And then in the second part, I'm going to deal with these defective concepts. And I'm going to basically do the following thing. I'm going to look at some lessons from the realism debate, not realism per se, but the realism debate more broadly. And I'm going to try and carry over those lessons to the case of concepts. So what kind of interesting things can we say about concepts, given some of these lessons that we learned, I hope we've learned in this debate. Okay, so let me begin with this, with the first part, the general debates over concepts, and with pluralism versus monism. Okay, so conceptual pluralism, the way I am expressing it here, because there are different kinds of conceptual pluralisms, this idea goes back some time, and this is not the first. I mean, I'm quoting or I'm citing Malcolm here. This is Norman Malcolm, who's writing on epistemology, but it probably goes back even further. I haven't really done as much work to see how far back it goes. Malcolm suggests in 1952 that there are two concepts of knowledge. There's an ordinary concept of knowledge, and there's a philosophical concept of knowledge, and we should treat those separately. Right? It's a kind of a pluralistic view. Since then, lots of broader conceptions of conceptual pluralism have emerged. So we focus here on the following one, according to which, for any given category of interest, there are multiple and equally legitimate concepts. Right? This is very broadly defined also, and you can disambiguate this kind of pluralism into different ways. So for example, there's some equivocation here between compartmentalized versions of this view of the conceptual pluralism view and non-compartmentalized ones. So what are the compartmentalized ones? It's where you basically, let's say, you take this category of interest and then, let's say we talk about the domain, you can divide up this domain, and then there are different concepts that apply to different parts of the domain, but there's no real rivalry, in a sense, between the concepts, because they're complementary in a sense. They're trying to cover the whole of the domain. Right? Whereas if you have an all-encompassing version of pluralism, then as you can imagine, it's kind of a bizarre for me idea of a pluralism, even though there are some people out there who are expressing this kind of views, which is something like for any given domain, you can basically have equally legitimate concepts applied to exactly the same domain, right? And they are competing in a sense, but they're competing, but with no real essence of competition. Because why? Because they're all equally legitimate, right? That's what the pluralism says, right? So if you want an analogy to understand this kind of pluralism, it would be something like the underdetermination debate. So you have all these different theories. They're all meant to be about the same world, but somehow, so they're all rivals, and somehow they're all, well, to some extent, you might say they're all equally good, right? Why? Because you can't choose between them, at least. Okay. So, this has become a widespread view, right? In fact, here's a quotation from Chalmers, who goes as far as saying, "I'm inclined to think that pluralism should be the default view for most philosophical expressions." There's a paper, a nice paper by Taylor and Vickers, very recent one from 2017, where they actually go and do the legwork and come up with a list of concepts towards which pluralist views have been taken, independently of all the other concepts, right? It's just, these are kind of separate debates, but people are making the same moves in these different debates, right? And they list a bunch of concepts, including consciousness, explanation, health, intelligence, natural kind, physicalism, probability, scientific method, and species. Something that troubles me about that paper is that even though they start out by saying, well, we're going to talk about scientific concepts and the pluralism there is towards them, they end up giving a lot of examples of philosophy of science concepts, and then they say, oh yeah, well, we have some philosophy of science concepts here. Okay, so I'm going to add some more here to the list. I'm sure some of you guys might even mention a few more. So ad hocness, pluralism with respect to ad hocness, causation, freedom, justice, truth, and reference. Okay, so now I am also guilty of having been bitten by the pluralism bug, right? Twice, in fact, in print. So I have this paper from 2011 in Synthèse. It's called Saving the Intuitions for Analytic Reference. And there, I basically look at different conceptions of reference. So, the standard descriptivist, causal, historical, causal descriptivist, variations, and so on. And I go through all of these and I say, well, look, we can really take a pluralist approach here. And the same thing I do, in a sense, here. So this is a paper about ad hocness from 2016. It's actually in a volume on fundamental issues of artificial intelligence, on the theory of and philosophy of artificial intelligence. And here I accept that there's lots of different notions out there about ad hocness, but I do try and do something which is not so pluralist in a sense, because I say, well, okay, it's pluralist in a particular way, I should say, in this more compartmentalized way. I say, look, I'm not so interested in all these variations of ad hocness. I'm more specifically interested in a particular subdomain of what people mean by ad hocness, and I'm going to try and define that. And that is something like the contrivedness of a theory, right? Because some people talk about ad hocness in terms of how a theory is contrived. Right? So I come up with a way of understanding ad hocness. So it's not ad hocness anymore. It's what I call the monstrousness of a theory, right? And it captures this idea of contrivedness. It's just basic. The basic idea is that if you put together content that doesn't really fit well together, and how do you realize whether it fits together? Whether it's confirmationally connected, which means whether if you confirm one part, you can confirm the other part. If that doesn't happen, if there is no such confirmational connection between different parts of the theory, then these are ad hoc, in this very specific way, contrived components. Okay, so what were the reasons for me to go pluralistic in these papers? Well, my reasons were that intuitions about these categories vary to the extent that taken together they form an incoherent set, right? I mean, we know through all these discussions on experimental philosophy and so on that there are at least, I mean, okay, some of these results might be contested, but it seems to me pretty reasonable. In fact, I even see it in my own self, right? My own intuitions vary from time to time. So you couldn't really expect that there is one concept that's going to do justice to all these intuitions. And in particular, in some of these papers, actually in both of these papers, I specifically try and show where these intuitions can in fact be incoherent, right? So you couldn't really possibly come up with one coherent concept that does justice to all these intuitions, right? So that's one reason. And then, of course, the second reason is that by devising different concepts, we can do justice to subsets of these intuitions that are coherent, right? We can find subsets that are coherent and try and see if we can find some nice definitions that do justice to these intuitions. Okay, so I said that already, right? So I thus endorse a form of pluralism, though I stress that some concepts may require a monist treatment, right? So the door is still open for some kind of monism there, right? Okay, so what is conceptual monism? Well, this was the default view up until recently. I'm not sure if there is a default view right now because there's lots of conceptual pluralists out there. Don't think it was in this survey, philosophical survey that I took. I also participated in more than 10 years ago, probably now. But perhaps in an updated version of this philosophical survey, you can ask, Chalmers and the others can ask such a question. So this was a default view, conceptual monism, and we can define it here in contrast to the pluralist view. So for any given category of interest, there is a uniquely legitimate concept, right? Okay. So this view is, of course, intimately tied with the classical view of concepts and conceptual analysis. I'm going to talk about these some more in the slides that follow. So just bear with me. Okay. Let me now make a more substantial point, since I'm giving you a little bit of an introduction to conceptual pluralism and monism. There are some categories, for example, categories like furniture, right, that are clearly dependent on us. Right? These are categories that we've constructed, we've invented, because they contain objects that are useful for us, that serve our needs and wants. Now, it's pretty clear that there is some variations in the needs and the wants that we have, right? Different people might have a disability, you might have, you name it. There are different, it's pretty clear that we have different needs and wants. There is at least some variation in relation to our needs and wants, which means that if we were trying to do justice to such categories via a concept, it's not likely that a single concept would suffice to capture all we mean by them, right? Moreover, perhaps this is a more significant problem. Such categories are often not clearly delineated, right? Which means what? Which means that they have kind of fuzzy boundaries. We're not even sure sometimes when we get asked, what is this a, I mean, we do these tasks actually in psychological experiments, especially, not only, but especially in the case of children, to see if they mastered use of a concept, but we can do it also on full adults because there are unclear boundaries in these categories. So, for example, there are things like this object here. This object is it chair? Is it a functional chair, or is it just a piece of art? For me, it's unclear, right? The category of furniture and the subcategory of chair is not a category that has clearly delineated boundaries. If that's the case, then why should you opt for a single concept that tries to, especially if that concept is meant to be clearly circumscribing the boundaries, right? Why not opt for a bunch of concepts and then move between them, right? Okay, so that means that with respect to these categories, attempts to box them in are a bit futile. Or at least to box them in completely. I don't want to be extreme here because I even had some extra comments here. I moved them just to keep the slide fairly clean, which were things like, okay, and that's why I say here, there's some variations of needs and wants. Obviously, there's also quite a bit of convergence, which means that the underlying need, there must be some kind of core underlying meaning to some of these concepts. Okay. There are also not just the dependent categories, there are also some independent categories. So a kind of subatomic particle, for example, is independently fixed. Such a category is independently fixed. It means that it doesn't depend at all on us. It's just out there. Perhaps our list of particles, fundamental particles, might be completely incorrect. So put that aside now. But just imagine, let's just to frame the discussion, because we can't really start with absolutely no assumptions whatsoever. Suppose there is a world out there, and suppose that this world does have some fundamental particles, right? Then these fundamental particles, obviously, I mean, by definition now, we're already setting this up in such a way. They're mind independent, right? So I'm not going to argue for mind independence now. I'm assuming it. Okay. Our needs and wants obviously should not matter then here, right? They don't matter in relation to these categories. They just exist independently of us, right? Moreover, such categories have clear boundaries, right? What does that mean? It means that membership in these categories is clearly delineated, right? So, in fact, errors in identifying those boundaries would lead to predictive and other failures, right? So, for example, if you identify an electron you put it in the class of neutrinos, then you'll soon get in trouble and vice versa, right? Because one kind of entity can interact very much with a lot of other things. The other kind of entity is very weakly interacting. Okay? So what's this point then? So I've introduced you to this debate between conceptual monism and pluralism. Then I've given you these different categories, the dependent categories, the independent categories. What's this all about? Well, I'm coming to it, and that it's the hybrid stance. It's a proposal of a hybrid stance towards this debate. One can take a hybrid stance towards the debate on the basis of the above considerations, namely the distinction between dependent and independent categories. Right? So here's a tentative suggestion. This is so the whole of part one is more tentative. So I'm still working on these things. I'm still thinking about these things. But here's a tentative suggestion. Right? You might say conceptual pluralism ought to be permitted, right? Not forced upon us, but because we might just end up actually only having a single concept for whatever reason, but it should be permitted when the categories at issue are artificial, or I should actually say, I switched the terms, because before I was talking about artificial, then I made some modifications to my paper, to the talk, to talk about dependent and independent, when they are dependent, let's say. Right? But these two things correspond quite well. Okay, so conceptual pluralism, again, ought to be permitted. So we ought to be allowed to be conceptual pluralists with respect to categories that are dependent on us, right? But conceptual monism ought to be required. We should require conceptual monism of what? Of categories that are independent, that exist independently. Okay? I have a little qualification here, and the qualification is that, of course, I'm thinking of the ideal case when I talk about conceptual monism here. I'm thinking about, and let me explain a bit more why would that be the case, right? I'm thinking of the ideal case. If there is, suppose that there are all this bunch of things out there in the world, they exist independently of our minds, right? And suppose that they're also organized, just like we think these subatomic particles are organized, namely that you can call yourself as belonging to the class of electrons if you have a certain charge. You can call yourself as belonging to a class of neutrinos if you have you don't have charge and you have a particularly very small mass, so very low mass. So there are very specific criteria that tell you that all these things are more or less indistinguishable. Perhaps the only thing that you can distinguish them with is the spatial temporal location, right? So that means that all of these are just instantiations of one and the same kind. I'm not going to talk about the metaphysics of this kind, whether it's a universal or something else. Again, putting those things to the side. Right? If that's the case, right, if there are these natural groupings, in a sense, and you want your science to understand the world, then surely you want your science also to capture all those natural groupings. Right? And if such a natural grouping is has this clear boundary, then there's only one solution actually to this problem. You can try, of course, and grasp this notion, and that's why I said, sorry, let me be very clear. In the ideal case, suppose we have like a final theory, then in that ideal case, then there would only be one concept that's describing this natural class. Right? In the non-ideal case, and that's what the qualification is saying here, you may have a bunch of different concepts that try to get at the same thing, and it's only because we're not quite sure, we haven't got there yet, that we're allowing for these concepts to coexist, right? But ultimately, we want to get rid of them. Why? Because it would be, think about it, if the concept that we end up with includes in its extension, let's say, more things that are actually included in this natural class, then it would be an incorrect, it would not be an accurate concept in a sense, right? I'm going to talk about it a more precise way of talking about this property later on. That's why I'm being a bit loose now. Okay. So good. If it doesn't include all the things that are included in the natural class, then again it's defective in something, right? If there are two concepts that are they basically have exactly the same extension, and they're getting this extension exactly coincides with the objects in that natural class, then for me those two concepts are basically reformulations of one and the same thing. If there's any real difference between them, it would have to be intentional, but the intentional stuff is the fluff here, because if you reach the end of the road and you have this concept, then why do you need all the intentional stuff anyway? Right? You just need to circumscribe the concept correctly, so the category correctly, and that's it. Okay. Okay, so that's the first general debate. Here's the second one, classical. This is going to be shorter, classical versus prototype theory. Now, the classical theory of concepts, as you guys probably know, also known as definitionism, asserts that all compound concepts are understood in terms of necessary and sufficient conditions, individual and necessary jointly sufficient conditions. There are well-known problems with this approach. For example, the variability of intuitions across several dimensions. So all these experimental philosophy studies that show influences of age, culture, and so on. In fact, some have even gone as far as to announce the classical theory's death. Here's a quotation again from Taylor and Vickers, who also mentioned Fodor. They say, several factors contributed to the death of definitionism, one of the most prominent being, as Fodor notes, that there seem to be no uncontroversial examples of definitions of any concept whatsoever. It's dead. If you haven't heard it, if you haven't heard the news, conceptual, so the classical theory of concepts is dead. Okay? And for those who are watching online, it's dead. Okay, so there is, of course, an alternative. There are a few alternatives. Again, I don't have time to go over them. I'm just going to talk about prototype. Prototype theory was developed by Eleanor Roche, and I forget the first name of Mervis, 1975. And they basically borrow from Wittgenstein's family resemblance relation, and they argue that membership in a class or concept is graded on the basis of similarity judgments to a prototype. So here's an example. So suppose we're talking about a class of birds. That's a robin. Presumably that could be our prototype. And then it might have some features that are prototypical features. And then if you want to decide whether there's an object that should be included in the class, then you see how similar it is to that, to the robin. So I don't know where you want to put the penguin. Maybe you want to put it here. Maybe you want to put it all the way away from a robin. But depending on how close these other objects are to a prototype, then they deserve to be included in the class. Okay. So there are several empirical studies that indirectly try to show how prototype theory is a winner here, and they seem to be doing quite well, even though there are some studies that do exactly the opposite. And there are also problems with this view, though, right? So one of the major problems that people have been pointing out is that this theory has difficulty dealing with compositionality, so compositional concepts, right? So you can take two concepts and you can form a composition out of those concepts, or vice versa, the decomposition of those concepts, and the kinds of features that you get in the atomic ones, let's say, might not be, if you put them together, the composition are not present. I think like a good example is pet fish. So fish is meant to be, I don't remember how does that example go? It's meant to be flashy and colorful pet fish, but fish on its own doesn't have such a prototypical feature, right? But the pet fish does seem to have this feature. Okay. I'm not going to say whether or not this, I mean, there are also replies to how to deal with compositionality. Again, not covering it. But I just want to go back to the classical theory and just say the following thing. I'm actually quite fond of both theories. So I just think that the proclamations of death are premature, as is often the case. People just announce the death of something and then maybe extreme versions of that view are dead, right? But we forget that there are more reasonable versions of a view. Okay. So for better, first of all, notice that for better or for worse, the literature is still replete with examples of the theory in action. So if you're saying that the classical theory is dead because it's no longer being used, I mean, just open and maybe you've not been reading any recent articles in all the journals, in all the top journals, because there's lots and lots and lots of examples of classical definitions being given. Right? More importantly, perhaps, for the purposes of this talk, the claim that there are no controversial examples of concepts treated with the classical theory is completely and utterly false. So here a couple from science, atomic number. There's no controversy about what atomic number denotes, right? The atomic number is just the number of protons in the nucleus of an atom. End of story. Right? Isotope, that's distinct forms of the same element, each of which contains a different number of neutrons in its nucleus. End of story. There's no discussion there. Now, there is a sort of controversy that one can never get away from. And that is a controversy that arises over history. Right? So you might, in fact, over history, move towards different conceptions, but that doesn't mean that at a particular time, at a certain time, at a certain point in time, you don't have uncontroversial cases of these concepts. And that's all I need here. In fact, I would even go as far as saying that, look, these have been pretty stable for quite some time, atomic number and isotope. I really wonder if they do change, they probably change a little bit. So I really wonder whether even in this weaker sense of controversy, we can accept that that's something that's going to happen. Right? Finally, the classical theory versus the conceptual analysis is not wedded to the idea of saving intuitions. Right? So one of the main objections, again, remember, towards the classical theory is the idea that there's a variability of intuitions. But the classical theory, even though it's often presented as almost synonymously with conceptual analysis, it's not exactly the same thing. Remember how I gave the definition here? And I'm not the only one giving this definition. I found it a bunch of times in various articles, right? It just says all compound concepts are understood in terms of necessary and sufficient conditions. There's absolutely there's no suggestion here that what does the testing of these definitions are intuitions. Right? Whereas conceptual analysis is not just the theory of concepts, it's in addition to endorsing the classical theory of concepts, it also endorses the view that intuitions, a priori intuitions, are doing the work. It's a kind of a methodological approach to doing philosophy. Right? Okay. So why am I saying all of this again? Well, because I want to go for yet another hybrid view. Right? So I've already presented you with one hybrid view. Here's another one. It should be clear that we expect different levels of precision from different concepts. Some concepts like the above cannot be but regimented, right? So these concepts, I mean, these are strictly kind of structured. They have to be regimented so strictly. But other concepts may be more messy, like happiness. Happiness is a really messy concept, right? Because I am very sure that even within yourselves, you would call something happy one day and another day you would disagree with yourself. Intelligence and so on. Right? These are more fluffy concepts. On the basis of the above considerations, we can devise another hybrid view. Here's a tentative solution. Again, this is very tentative. I'm just working towards something like this. So we can say, so proposition 3 is something like necessary and sufficient conditions should be sought when absolute precision is needed, for example, in relation to natural categories, or what we called earlier independent categories. The fourth proposition is similarity to a prototype should be sought. Actually, here I just removed other variations, other views. So you might even want to include reflective equilibrium as another kind of competitor, or there are these mixes between conceptual analysis, the classical view and the prototype view. So there are other views here that can enter here. And the point is that these should be sought otherwise, namely when absolute precision is not needed, and in particular when non-natural, it's not clear that when non-natural categories are, with respect to non-natural categories, it needs to be the case that we shouldn't go for necessary and sufficient conditions. You can still go for such an approach, I guess, but whatever is left out of this definitely should be included in this. That's the general idea. Okay, so here's the more substantial part of the stuff that I have developed a little bit more. Okay, so dealing with defective concepts. So we begin with some lessons from the realism debate. Before I say anything, let me just qualify, again, to keep the slides a bit neat. I basically talk about theories or concepts, and I really mean scientific theories or scientific concepts, okay? So, lesson number 1. Our best theories may be very far away from the truth. So this is in relation to my rude comment earlier to Quentin. I apologize, Quentin, for being rude. But, so this is, in a sense, there are various people in the scientific debate who deny, including realists, who deny that we have approximately true theories, right? Here are 2 examples of realists in Noto and Kuipers. Van Fraassen is not a realist per se, but he has done similar kind of work in that he's coming up with a kind of a weaker notion of truth, namely empirical adequacy. So you can also advocate, these guys advocate notions of partial truth. So what's the motivation for saying that our best theories may be very far away from the truth? Well, we have no independent access to the true theory, assuming that there is a true theory. Right? If we had, then we'd be able to say, oh, this current theory is so far away now from, we could probably come up with a metric and say it's this far away from the, and therefore it's approximately true, or it's not so, it's not approximately true. Right? But we don't have such independent access to the full truth, right? To let us judge the proximity of our current theories. Instead, we use weaker notions like empirical adequacy and partial truth to do some good work, but we can't really determine how close we are with those notions. So just to give you an example with partial truth, you can still talk about and make sense of increasing the partial truth of a theory, even though you don't know how far away you are from the actual truth. Right? Here's an example from of the kind of situation we find ourselves right now that also motivates why our best theories may be very, very far away from the truth. The best theoretical hope we have for like complete physics right now is string theory. And according to string theorists themselves, not their opponents who don't even want to hear the word string theory, there are up to 10 to the 500 types of string theory. Now, in order to, and these are rival string theories, okay? So in order to determine which one is correct, we would need to build accelerators which would have millions of times more, that operate at millions of times more energy than we currently do. And that seems very, very unlikely that it's going to happen anytime soon. So this is kind of pointing to, of course, we might still be, our current theories might be very close to the truth, but this is kind of pointing to if a string theory is correct, then this puts, and in order to test it, to test which of those string theories is the right one, then you can see how significant the problem would be. Okay? Lesson number 2. At least some parts of even our best scientific theories must be removed or replaced. Right? So I'm trying to also be a bit kind of neutral with respect to the realist and the anti-realist here, right? So Duhem, for example, makes these comments. Kitcher, Votsis. What's the motivation for this? Well, past theories have had both false and idle parts. That's pretty clear. Everybody agrees on that, right? Such parts must be removed to make progress. That's also pretty clear. Well, whatever kind of progress that is. Since the content, but notice now, this is just a simple logical point. Right? Very simple logical point. If the content of, we know that the content of a derived conclusion, it's derived, right? So the content must be included in the premises. Right? So since the content of the derived conclusion originates in the premises, then we must remove or replace some of the premises. It's as simple as that. Or if you want to put it in terms of falsity, because oftentimes when we teach these things to undergrads, we say the truth of the conclusion is, in a validly derived conclusion is buried in the premises. But you can also say the falsity of a conclusion, of a validly derived false conclusion, is buried in the premises. That falsity is in the premises. You want to get rid of it, you have to either remove or replace, because replacement, of course, is removal and addition. Okay. So again, consider, just to put things in context, our best theories, of course, quantum theory, quantum field theory, and general relativity are still at odds with each other. So we know that some modifications must be made, something has to give way. So we know that some parts need to be replaced. Okay. Here's a third lesson. Successor theories must be such that they degenerate into well-confirmed parts of their predecessors. Again, it might sound like it's a realist view, but this is kind of I'm trying to stay as, I hope, I didn't leave anything too realistic in there. This is also holds for empiricists like Manfasa, in a sense, right? Why? Because if you talk about the well-confirmed part as being the success of in a kind of an empiricist-friendly way, success of the theory, right? Then your new theory, you also want it to be successful, right? So you want your new theory to be such that it degenerates into the well-confirmed. So it saves the success of the old theory. Okay. This refers to so Post has this correspondence principle that he takes from Bohr. So Rettel also talks about the correspondence principle. It's basically this idea. It can also be heuristic towards constructing new theories, right? So motivation here is that genuine empirical success cannot be thrown away, but must be incorporated into subsequent theories. Why? Because if it's genuine, then why would you want to throw it away? If it's really genuine, then you have to find a way to keep it. Right? That's why when designing new theories, we want to preserve that success. Consider again that, as is well known, non-classical equations reduce to corrected versions of classical. Right? So, to the extent, in a sense, that the classical ones were correct, that they reproduced phenomena to a reasonable level, then we should be able to recover that success from the new theories, right? Under some limits. And the final lesson, there are more, but I just don't have time. Successor theories may be such that they exhibit structural features analogous to those found elsewhere in nature. So I say may here because there's no guarantee, of course, that there should be such analogies. So Darwin, of course, made an analogy between artificial selection and natural selection. That's one way of finding these patterns being reproduced all over. Mary Hesse talks about analogies. Darden talks about analogies, I think, in the context of she talks about how the concept of a field was constructed analogously to existing notions. Okay. So motivation here. Well, we have hard constraints about how to construct theories, but we also have some soft ones, and this is one of the soft ones. Right? It's a kind of a heuristic. Right? Analogical reasoning is one which has met with some success across the sciences, sometimes with failure. So somebody yesterday, I think it was Ottavio, maybe he was. You opened your eyes, so you're not sleeping. He was talking about Vulcan, the planet Vulcan, which was postulated to save the perihelion of Mercury. That was an unsuccessful analogy from the success enjoyed by Neptune, postulation of Neptune. Okay. Consider, nature clearly exhibits some repetition in its blueprint. So again, I relate this also to my comments earlier about simplicity. It seems to me that whatever nature is, we might not know how simple it is, but one thing we do know, it's not maximally complex. Okay? And this is one way in which we can understand it. if there are patterns that seem to repeat themselves, that's kind of an economy of nature. Okay? So think of Coulomb's law and Newton's gravitation law. They're both inverse squared laws. This is a kind of a repetition of a pattern in nature that seems to be quite nice and economical. Okay. So there are some nice concepts here. I'm also probably worse than Moises in terms of time management, but you forgive me that because A, I'm a keynote, and B, I'm the last one. So what are you going to do? Where are you going to go afterwards? Huh? Okay, I'll try and be brief though. Okay, so there are two nice logical notions we can use here to understand these kinds of rules, right? And these are the notions of logical weakening and strengthening, right? So regardless of whether one uses them explicitly in the lessons we mentioned before, two notions appear to be at work, especially in relation to lessons 2, 3, and 4. I can even make a case for lesson 1, I think. And what is logical weakening? Well, it's basically decreasing the content or the non-analytic logical consequences of a theory. What's logical strengthening? It's increasing the content or the non-analytical logical consequences of a theory. Okay? Oftentimes the two can be used together, so you can logically weaken and strengthen at the same time, in which case you have some kind of logical replacement. So here are some examples of logical weakening and some examples of logical strengthening. So without assuming an ether medium, so without making an assumption about the ether and what kind of properties it has, you can still maintain Fresnel's equations, and these still describe the reflection and transmission of light, regardless of how these equations have actually been derived, because you can also derive true conclusions from false premises, so long as there's some truth buried in there, right? If there's a complex sentence in there and some kind of truth buried in there, you can still do that, right? So this relates to lessons 2 and 3. So that's what that means here. Another example, without assuming heat as a substance, right? So without assuming this caloric idea that heat is a substance, you can still, which Carnot did, Sadi Carnot. Carnot's principle still describes maximum efficiency limits. We also have cases of logical strengthening. With the assumption that some planets move faster and heliocentrism, with the assumption that some planets move faster, you can use heliocentrism to explain or derive retrograde motion. You're logically strengthening. You're increasing the content, and you can get these results. With additional assumptions, including Newton's second law of motion, Kepler's laws imply classical gravitation. So there are people out there who do these derivations of Newton's law of gravity from Kepler's laws and some additional assumptions. Okay. So that's all I wanted to say about the lessons from realism. Now I'm going to apply them in the context of concepts. I need another 5-7 minutes and then I'm done. Okay. Okay. So in the same way that truth plays a role, the role of goodness for theories, we need a kind of corresponding notion for the goodness of concepts, right? And this is a good candidate, extensional adequacy, right? It seeks to capture something like the representational correctness of a concept. So here's Taylor and Vickers again, who try and define this or give some kind of a loose, give us some kind of grasp of this idea of extensional adequacy. They say any answer to the question what is X should not exclude any cases which certainly are X, and not include any cases which certainly are not. I agree with that, but of course, it's a little bit loose, right? The characterization leaves a great number of cases unclassified, and its objectivist credentials are not obvious. Remember, I want to make sure that there is some kind of representational correctness. So I have a reconception. I propose something here, which I don't even believe myself, but it's something, it's a kind of a stepping stone towards a proper definition of this notion of extensional adequacy. It would be something like this, right? So I say here a substantive scientific concept. Substantive, I mean not a methodological one, but something that's meant to be aiming to capture a class out there, or a class of things out there. In that respect, substantive. A substantive scientific concept is extensionally adequate even only if its extension contains as elements all and only objects of the same natural kind. Right? So it would be that it's extensionally adequate, so in a sense, fully extensionally adequate if there's a class out there and you're completely capturing all and only the objects in that class. Right? So what's good about this? Well, what's good about this is that extensional adequacy is decided on something external, much like truth, right? So we said we want goodness, or just like we have goodness for theories, we want goodness for concepts. And since goodness for theories is truth, it's something that's supposed to be in robust notions of truth that I've been assuming here, supposed to be something that corresponds with facts. In this case, it's correspondence with objects that belong to the same grouping, right, out there. Right? What's the negative? One of the negatives of this approach is that the way I defined it, it's as if I'm restricting all concepts to natural kinds, and that's extreme, right? That's presumably there are other kinds of useful concepts out there which we want to call scientific concepts, and yet they're not really natural. They don't really correspond to a natural kind. Right? We still want to call them substantive in some respect, but yeah. Okay. We can stretch the analogy further, right, and define weaker notions because we're interested in the weaker. Usually, we don't get to see truth. Absolute truth, so probably we don't get to see absolute extensional adequacy, but we might want to define notions like approximate extensional adequacy and, more importantly, partial extensional adequacy. Maybe something like this. There is some overlap between the extension of a concept and the set of objects that makes up a natural kind. Okay, so now this is the key bit, which is I'm translating now these lessons from the context of theories to the context of concepts. So the first lesson is that our best scientific concepts may be far away, very far away from extensional adequacy. Now, the adequacy of concepts is surely judged on the basis of currently accessible objects, and that this may be severely limited, right? If you look back in history, we didn't have all sorts of instruments, so we couldn't really access a lot of the things that we need to access in order to determine the extensional adequacy of concepts. So here's an example. Classical conceptions of fundamental particles are radically different than quantum ones, of course, and that's meant to show a historical example where there's quite a bit of difference. So the concept in the past is very far away from the concept in the future, and by analogy, in a kind of a PMI-esque way, you might think, well, it might be very far away from the actual, the concept we end up with. Right? So here's a diagrammatic way of thinking about this. There's a bunch of objects out there. Suppose the red ones are the ones that we want to have. So this would be the ideal conception, but this is our current conception. It captures a few of these red ones, but it also captures these other ones. Right? So that's lesson number one. Lesson number two. At least some parts of the extension of even our best scientific concepts must be replaced or eliminated. Just like with theories, we replace parts of theories, you can replace parts of concepts. You can decompose or partition concepts and then replace some of the parts of their extension. So past concepts have either corresponded to nothing or to things that are significantly different in their features. Since the extensional inadequacy of the concepts originates in those features, they must be replaced or eliminated. Right? So if there are some features that define, in a sense, that guide which objects are included in the extension or not, you can think of them as the conditions of the definition, right? Then you have to remove or replace those in order to get rid of some things that are not quite correct. So here is a current, suppose that's our current correct conception. We may move simply by removing these three green objects, we move to a new conception, which is better, at least in the sense that it doesn't capture any more of these unwanted objects, right? An example here would be light and caloric. So when the first table of elements were created by Lavoisier, light and caloric was in fact included as elements, right? But then they were removed, and nowadays we no longer talk about them as elements, right? They're not kinds of things like oxygen and hydrogen and so on, right? Here's also replacement, right? Replacement would be something like this. You remove these, but then you add also some other ones. So we're shifting this to show that we're adding some others. Lesson number 3, almost there, almost done. Successor concepts must be such that they degenerate into the extensionally adequate part of the predecessor. Right? So you must preserve the extensional success, in a sense, of the predecessor concepts. Genuine extensional adequacy cannot be thrown away, but must be incorporated into subsequent concepts. So here's an example. The relativistic concept of momentum reduces to the classical one when the Lorentz factor is neutralized, right? So you get more or less, let's say, the same predictions from the two theories. So you can imagine that as being, so this is the old conception now, and you move towards sorry, you start with the new conception, and then you can basically move backwards under some limits to the old conception, and then you capture some things that perhaps you don't want to capture, but you also capture some things that you do. Okay. And lesson number 4 is this analogy lesson, right? In the context of concepts, successor concepts may be such that they're analogous to existing concepts in other domains. So besides being driven, data is a big driver of change, of course. That's the most important driver of change. But there are also some heuristics. Analogical reasoning is one of them. And even analogical concepts have enjoyed some success. So taking the same example as before, but now focusing on the concept side of things instead of, let's say, a whole equation, electrostatic force, the electrostatic force concept is structurally analogous to gravitation, to the gravitation force concept. There are also, here's another example from a paper that I wrote with Gerhard Schulz on the caloric. So there's an element of the structure of the caloric which is analogous to, which is actually analogous to this case of electrostatic force, because you have this repulsive and attractive forces, right? And this element, it was embedded in the caloric theory. So the caloric was thought of as being attracted to ordinary particles, but repulsed other caloric particles, right? That can explain, in turn, the expansion and contraction of bodies. And that, even though we throw away the caloric, the expansion and contraction of bodies is structurally analogous. The modern explanation in terms of the kinetic theory of gases is structurally analogous to the old, to the caloric account, right? So here I have something like an isomorphism, right? So you have a concept, and then you try and maybe apply something like an isomorphism and see if you can use that concept in another domain, and if it works, fine. Okay, so just like we had logical weakening and logical strengthening, we can have conceptual weakening and conceptual strengthening. Conceptual weakening means decreasing the extensional boundaries of the concept. Conceptual strengthening means increasing those boundaries, right? And of course, if you put this together with respect to the same set of objects, then it would just be replacement, right? So you remove something and you replace it with something else. Some examples, like one more slide after this. Conceptual weakening. So the definition of planet, the concept planet, was tightened by the International Astronomical Union in 2006, as you all know, to exclude Pluto. So it's a kind of a conceptual weakening. The concept of mental disorder has been tightened over the years to exclude cases like homosexuality. It started like some kind of sociopathic disorder, and we moved on to all sorts of various the epicycles upon epicycles, until finally they decided, oh, let's just get rid of it from the DSM. Conceptual strengthening, the current concept of star widens the Ptolemaic one, where the number of such bodies is fixed. Why is it fixed? Because it's meant to, these things are meant to be neither created nor destroyed. They're meant to be at exactly the same distance on a sphere that surrounds us, and so on. Our modern understanding of genetic information also has been widened to include things that before we thought had no, absolutely no functional value. So we've included now non-coding DNA and RNA, which regulate the expression of genes. Right? Okay, so to sum up, I had these two tentative proposals in relation to the two general debates, that pluralism is permitted in relation to artificial categories or dependent categories, and monism required in relation to independent categories. The second proposal was that the classical theory should be sought when absolute precision is needed, for example, in the case of natural categories or independent categories. And then I talked about 4 lessons in the realism debate, 3 of which can be explicated using, at least 3 of which can be explicated using logical weakening and strengthening. And then I transported these lessons in the context of concepts, where I also define these notions of conceptual weakening and strengthening as analogous. Thank you.
We have 1, 2, 3, 4, 5, and let's hope we have enough time. You're entirely right.
How many minutes was I over?
10, but
Okay, 10 is not bad. It's, by my standards, it's amazing.
we are only constrained now by physiological needs and wants.
Yeah.
So, okay, one please.
Okay, thanks. I think this is a really interesting paper, and I think there's a lot of things there that you're definitely quite right. And one question is, even at least it wasn't clear to me why we shouldn't be pluralists about concepts, even the natural categories, right? In the sense that, as you know, often within a given moment in a scientific field, particularly when a theory is being developed, there are conflicting concepts about the same thing. So think about the concept of atom, right, around the turn of the 19th century, right, at the beginning of the 20th century, right, and what the form is, what kind of thing it is, how it should be thought of, and so on. And so those things are often refined in ways that I think the last part of your talk nicely captured, right? Because you do have these dynamics of refinement of concept.
Absolutely.
As new evidence comes in, problems that will emerge, theoretical difficulties that come up. Now you may say eventually, as you said, I think earlier in the talk, maybe in the long run, we end up with a single one. Okay, this is the concept. The question is, we never reach that point, right? And even now, right, if you think about the alleged fundamental physics, we don't have any, but I would not be surprised that a lot of those concepts will change dramatically once, for example, even quantum mechanics, which was thought to be, this is a great achievement. Now we have quantum field theory, which actually is quite different, but there are all additional problems with it. So I think to bank that eventually we reach a point where those concepts will be sharp enough to be monistic about it. Seems to me a bit unrealistic.
Okay, let me.
Just one comment also. Given the dynamic account that you suggest with the lessons at the end, I think it would be very interesting to compare what you're doing with Lakatos' proofs and refutations, right? Because he has a very interesting account about concept formation and concept change over time in mathematics. And I think a lot of what he says there, I think that's actually probably the most beautiful book in philosophy of mathematics ever written. I think it's his best work.
I once spoke with Dammit, who thought that it was just horrible, that book. But I'm not saying I haven't read it myself, so I can't really pronounce judgment.
We read a paragraph of Dammit, and he cannot say, the way he writes is no commentary about that. But leaving that aside, I think the book, I think he captures very well salient features of mathematical practice and the dynamics of concept change. Even though it's very focused on a particular case study of classification of polyhedron and Euler's conjecture, I think a lot of those things can be adjusted and adapted to scientific concepts. And I think it would be very interesting to do that.
Thank you. Thank you for the suggestion. I'll go back. I mean, I'm familiar with this philosophy of science work because I was forced by John Borland to be so familiar. But in relation to the first point, I of course agree, because I mean you were agreeing with me anyway. And I thought you didn't even notice that I made this qualification, but you actually touched upon it. That I meant only the final concept must be. And let me say that I'm neither optimistic nor pessimistic about this, right? I just don't. It's consistent with my approach. What I was saying earlier, we just don't know how far away we are from it. It might just be around the corner. I really don't think it's around the corner, but I don't know. Maybe 200 years from now, maybe I really have no clue. It might be 2, it might be 2000, it might be never. Right? So I want to leave it open because it's definitely more interesting to entertain than a lot of the logically possible worlds we're entertaining, because this is the actual world, right? So I'm going to leave it in place, the monism, right? The possibility of monism.
Okay, so Kentan.
Yes, thank you. It was very interesting. I have a question about the idea of degeneration. That new concepts should degenerate into the old one. If I'm not wrong, you have an extensional understanding of this idea that the degeneration is like the extension would be more or less the same.
Something like that. It's a bit loose. I leave it a bit loose there because I'm thinking of also degeneration in terms of, but I haven't really translated it into my slides, right? Degeneration as in you might get objects which are similar to the actual objects, in which case it's not a case of really removing objects or replacing them or doing some function like that. Yeah, exactly. So it's a little bit more complex there, but that's a part which I haven't developed yet. I'll need to work on.
Maybe it makes more sense because to me an intentional notion of degenerate sense would make more sense because
I don't want to go to the intent. Don't get me wrong. I don't want to go to intention. Maybe I want to go to a more fine-grained notion of extension.
okay.
That's what I want to do.
But
The term I actually borrowed just to be factual about it. I borrow from Heinz Post, who talks about the correspondence principle.
Yes.
Yeah.
But yes, I remind that this idea of correspondence seems to work well for scientific laws, but precisely it seems that there is here a difference between the structural parts of scientific theories and the ontological part, ontological process. And all the realism debate was in part due to the fact that a lot of terms do not refer at all. So that's what I found with this notion, applying this notion of degenerations, which seems to work well for the structural parts. I found it hard to apply it to the.
I don't want to commit myself too much here because again, this is not fully developed. But let me say the following thing: the way I'm seeing this thing evolving. Even the non-referring concepts, these people were not. It's not as if we were saying that it took until the 20th century to get any intelligent scientists. These were people who were also doing experiments, like phlogiston experiments in the 18th century, right? And they were dealing with also real things. Right? Now, it's a bit tricky here as to what notion of reference you use, because there's a sense in which, if you're merely talking about descriptive, then there's so much of the description went wrong. But having said this, a bunch of us in the realism debate have been pushing back against some of these very naive claims that were made by the early realists and making sure that even phlogiston is so we want to take the Ladan challenge more seriously, right? We don't want to just offhandedly eliminate phlogiston off the list. The same thing with caloric, right? We want to say, let's look at the successes these theories have. And even with phlogiston, you can find some kind of correspondence between what the phlogistons were doing and modern conceptions of oxidation, right? So the point is the following, that if there are these correspondences, and you can't, even if you go for a descriptive account, then there's some part of the description that gets preserved. So even though you might not be able to say that the phlogiston refers to, or dephlogistication refers to oxygen, you can still say that there's something that unites those two, right? Namely, the description that can turn out to be correct. The same thing with caloric, and I can talk at length more about caloric because that was my baby. The phlogiston was something I did with Gerhard, and he was mostly responsible for that account. But so that's the idea. The idea is even with so the concepts themselves. Think about them. If you think about them in the way I mentioned earlier, namely that there's at least some kind of conditions that circumscribe what goes inside the concept, then those conditions might be, of the old concept, might be mostly incorrect, but there might be something correct about them. You want to carry that over, or you want to be able to move from the new one to the old one in a degenerative way, and you can show how this thing is done through the correspondence of the descriptions, right? Which determine the conditions of inclusion in the particular class.
Over here, Víctor.
Well, thank you. First of all, I've only three very little things. The first thing is to say a number of times that the truth of a conclusion must be based in the premises. And to say a bit less frequently, the falsehood of the conclusion must be based in the premises.
Of a validly derived.
Yeah, but the first thing I don't understand. Take the premise, the moon is made of blue cheese.
Yes.
Okay?
Yes.
And to derive from that, the moon is made of blue cheese,
Yeah.
or Ioannis was the last lecture.
Yes.
That's true.
Yes.
Okay, so that truth does not derive from the premise.
Well, okay. So in that particular case, I would say that if the restriction is the following thing. Is the following, right? All the conclusions that I'm interested in must be non-analytic conclusions, right? They're synthetic conclusions, right? Now, in order to derive that, you need a synthetic. In order to derive that proposition that you just mentioned, I don't even remember the moon is made of cheese or Ioannis is from Cyprus or something like that, right? You need at least one synthetic proposition in the premises, don't you not?
No, which you have. That's exactly.
Yeah, but precisely. So but the truth of the whole thing is also going to determine on having at least one synthetic proposition in that. You can't really derive it from nothing, right? So in a sense, the truth. I mean, this is the definition of validity, isn't it? We say that the content of the conclusion is included in the premises, right? It doesn't come out of nowhere, right? Here's another. One
Addition,
concept.
addition is valid, right?
Sorry.
Addition is a valid form of inference, right?
Yes.
From A to derive A or B.
Yes.
So I give you an example.
Yes.
From a falsehood A,
Yes.
I derive false A or a true B. What's
Yes.
the problem?
Yeah, that's not a problem. I'm actually accepting that, right? So here's another way you can do this. Okay, you could even deny. So there are obvious problems with this kind of destruction introduction, right? So some people have been arguing against the use of such rules. So you could, of course, eliminate very easily. You could just eliminate that rule in that case. So I'm thinking of the non-trivial cases here, right? So okay, here's another way, because this is the way I've been using it in my papers on confirmation, for example. These conclusions are not going to follow if you impose relevant restrictions in the way that you find in well, yeah, and Gerhard Schultz and so on, right? It's exactly that kind of thing. I wasn't thinking of these trivial cases, right? So impose relevant restrictions, you get rid of this problem.
So maybe let me say the other little things. The second was
so just let me go back to this point just to make clear. The point is the following, right? If you take the non-trivial cases, if it's a validly derived conclusion, it doesn't come out of nowhere, right? It comes out of the premises, right? So if there's a problem with the conclusion, you must fix the premises. That's the idea.
not according to the classical notion of
and we came back to that. I accepted that point, and I said, this is what you need to do. Actually, I should have said that from the beginning. The relevance restrictions.
I had the impression that for what you call artificial concepts, you have chair. So different people have different concepts of a chair, and the different concepts are well delineated. But you wouldn't have the impression that...
No, I didn't say that they were all... it's exactly the opposite, that the different concepts of chair that we may have are even those concepts are probably fuzzy. They have fuzzy boundaries, right? And that's why I gave this example, remember? I gave this example and I said, I don't even know whether that's a chair or a piece of art.
Yeah, but to the left of it, you have there, that was what confused me apparently. Moreover, such categories are...
Not clearly delineated, so they have fuzzy boundaries.
My mistake, I misread it. The third thing, could you say one more word on the fact that we would not need intentional stuff once we are at the end of the road?
Okay, so
let's assume by the end of the road that all humans are dead.
No.
But then we don't need
when we suppose I mean, what do we do with science? With science, we want to describe the world accurately. Maybe you want to talk about, debate if science does something else, right? But suppose you are describing it now accurately, completely accurately, right? Then is it going to add anything if I come along with my concept which is extensionally identical to yours, but it has different intentional hue to it. Is that going to add anything to our science, to our final science? No, that's the point.
Yeah, but final science also requires applications, requires statements about causes, and so on. And so the fact that in natural language today we use constantly relevant implications means that apparently we do not want to do it from in natural language. We do not want to do it purely extensionally. And that will not change
I think
by the end of
I
time.
think we don't want to do it purely extensionally, maybe for heuristic reasons, right? Because it's useful to think. So we are projecting, in a sense, we are thinking, how could this extension be if we had a better concept, right? And then we are coming up with all these intentions, all these different variations that might not correspond to anything. So it's very useful. But once you have the final thing, why do you need the extra fluff, the heuristics, right? If the heuristics is meant to get you to the end point, right? Once you're at the end point, you don't need the heuristics.
Yeah, but well, I think you identify the end point with the fact that we stop reasoning and thinking and acting. I think even at the end,
you can reason, you can still reason, but you would reason perhaps only deductively from now on, right? If you had all the, if you have the final theory, you know you have it, right? That's a big assumption, right? But suppose that's the case, right? Then what do? You just derive consequences all the time. You don't even do it yourself, in fact, you have machines do it for you. But it would be essentially the same thing, right? You don't need any, would machines need to have these intentions to do it would just slow them down if they had them, right? If machines could have intentions. Yeah.
Okay. With the permission of number 4, we have a request for a follow-up. I ask you to be chirurgical, please.
Right. So just on the point about concepts which are not, for example, the concept of chair.
Yeah.
You mentioned the view that about prototypes. You have a prototype and then some similarity relation. But I mean, you could have like a number of similarity relations, right? Between two things, there are infinite ways in which they might be similar. So I guess I was wondering if you could say more about the sort of similarity you have.
Okay, so this is a well-known objection that similarity, how do we deal with similarity and so on, right? So it's pretty clear that when people are making this, first of all, so I mean, the philosophical problem stands, right? So how exactly do we determine similarity? And I have a few things to say about it, but first of all, notice that when people are making experiments, even and they're asking questions like this, it's pretty clear that it's not an infinite number of properties we're considering. We're considering some very, very few salient properties, and there's a reason why those properties are salient, right? And it's kind of easy to make, it's not completely determined, but it's easier to make similarity judgments. It's not a completely uncomputable problem or something like that, right? Now let me say something more substantial about the philosophical, the broader philosophical problem. In my view, part of the problem with dealing with this problem is that people think that they can find a universal metric for similarity. That's completely nuts, if you ask me. Right? Similarity should be judged on the basis of context, because in different contexts, different things are going to be salient, right? So, for example, if you're looking at a photo of the night sky and you're an astronomer, and you see some dots, you're going to take those dots perhaps as being stars, right? If you're a particle physicist and you're looking at a picture of a bubble chamber and you're looking at particle tracks and you look at the dots, well, that's noise, right? Because the particles are the tracks, they're not the lines, the curved lines, not the dots, right? So the context is going to determine what the similarity metric is. Second point, this thing is not going to come out of a priori reasoning, right? We're not going to come up with a similarity, even for a particular context, what the similarity metric is. We're not going to come up with it a priori. We have to do some investigations of the world, and then we'll determine whether or not these are a good bunch of salient features on which to base a similarity metric on, right? And finally, there is some, believe it or not, just to go back to reality, right? Not just the philosophical problem. There is some interesting evidence and data out there about the convergence of similarity judgments of cultures that have never touched upon each other, right? So in Papua New Guinea, the Kedengban tribe, I think, came up with a classification of was it birds? It was birds, I think, which has been described as almost identical one-to-one mapping to our basically classification, even though these people have been isolated geographically from all cultures for, I don't know, thousands and thousands and thousands of years, right? Which makes it highly unlikely that it's through contact that they have this classification, which means what? Which means that there might be something, I mean, I can't really exactly say what the reason is behind this, but probably is a combination of how our brain is structured and how the world is structured that naturally gives us suggestions as to how similar things are and how, of course, identical things are and so on. Right? So,
Can you do the last two ones?
Okay.
So you argued for conceptual monism for natural categories, basically by saying what we want is a one-to-one mapping between our concepts and the kinds. That's only going to get us monism if we're monists about the kinds, right? Whereas if we're pluralists about natural kinds, this one-to-one mapping is going to mean that we should be pluralists about
monism about the, can you explain monism about the kinds and pluralism about the kinds?
Well, so like the cases that you gave are the clearest cases on the spectrum from independent to dependent, right? So, you know, the Higgs boson, we think there really is necessary and sufficient.
If you mean the biological cases, I would be the first to say
let's
those are independent in some respect, but I don't think those are from natural kinds. Yeah. So there is a kind of a divergence of these two notions, I think. Yeah.
Okay,
So I agree. I think so. Species, for example, it's something. First of all, it's something that's not fixed, right? I mean, there's something about the DNA that you couldn't just have any old thing popping up unless it has a certain structure of the DNA. But it's not each individual is going to have. I mean, all individuals of a species have a lot of variation in there, and the variation changes all the time, right? Because of mutations and so on in their genes, right? So, which means what? Which means that it doesn't look like it's a kind of a category that's well circumscribed. So it doesn't really satisfy the kind of condition I was mentioning earlier, that it has to be somehow. Did I mention this or?
Yeah. I mean, the picture I was thinking was where you say something like, there's a number, there's not infinitely many, but there's a number of different ways you can categorize species. So these, debates that taxonomists have. Is there just the North American beaver, or should we separate the U.S. beaver from the Canadian beaver? These are the kinds, right? And you could be a pluralist about kinds and think, look, there's just two kinds here, or three kinds here. There's this
I'm happy to be a pluralist there. I'm happy to call that even a scientific concept, right? And that goes, it relates to what I said earlier, that I don't like this definition of substantive. The extensional adequacy of a substantive scientific concept I gave earlier. Why? Because it's really tied to only the natural ones. And I fully see.
Are a proper subset
Yeah,
of scientific
exactly.
kinds.
Exactly.
I see.
And finally, Julia.
I will ask you my questions tomorrow. Let's go for tonight.
Okay.
Probably the others are more happy about this one. I can stay here forever.
I have several questions. So.
Thank you, guys. Thank you. Yeah, sorry. It was a stupid answer, my first answer, so I took it back afterwards with my. I was just thinking on the spot.